All right, so here's the next problem. Minimum of adjacent swaps to make a valid array. You are given a zero-indexed integer array nums. Swaps of adjacent elements are able to be performed on nums. A valid array meets the following conditions. The largest element, any of the largest elements if there are multiples, is at the rightmost position of the array. The smallest element, any of the smallest elements, if there are multiple, is at the leftmost position of the array. Return the minimum swaps required to make nums a valid array. So an important thing to note is it wants the minimum swaps. It doesn't actually want the sequence or the output array. So here's an example, 3, 4, 5, 5, 3, 1. It shows us what you're going to do is you're going to swap 3 and 5, and then you're going to swap 5 and 1, and this one's going to go to the left. So one of the one of the important things to note here is that 5 and 1 get swapped, so that's one fewer swap. And then here's an example of just one element. It says there's 0. The array is already valid, so we return 0. Some of the constraints. There will be at least one number, so you don't have to worry about the 0 case. And it'll be up to 10 to the 5. And then the numbers will be all between 1 and 10 to the 5 inclusive. So the first thing I like to do is sort of just look at some of the edge cases. So something that could only be one element, it could already be solved. There could be multiple min or max values, which is important because when you're searching, you want to make sure. So like for this one here, you want to make sure you swap this 5 to the right and not this 5 to the right. You see how that works? So how we're going to do this is the first thing, so don't actually do the swaps. This is important. So when I first looked at this, I thought you actually had to do the swaps, but you don't actually have to do the swaps because remember, you only need the minimum number of swaps. You don't actually need to do the swaps. So that's important to know. So what we're going to have to do is we're going to have to get min and max index, and then we're going to need to compute left swaps and compute right swaps, and then we're going to want to check if, so like for this case, the low and the high swapped, that's one fewer swap you need. So we'll just say check if left and, or we'll just say check if min and max were swapped. Cool. So let's get started on this. So the first thing we're going to want to do is find the minimum value. So dot front for int. So what we're doing here is we're trying to find the minimum, and we want the leftmost one. That's important. Again, so for this example with the 2 5s, you would want the rightmost one. So what we're going to do is we're going to start iterating from the left. So we'll say, so we can start at 1 because remember we initialized this to the first element. We'll say I is less than nums dot size I plus plus. This would actually be nums dot front. So we're going to say is if the min value, or if nums dot at I is less than min value, we'll say that the min I is equal to I, and the min val is equal to nums dot add I. And then we're going to do the same thing with the max. We'll say int max I is equal to nums dot size minus 1, and we're going to say int max val is equal to nums dot back, and then for should be an I up here, for an I is equal to nums dot size minus 2. While I is greater than or equal to 0, I minus minus. So we're going to iterate in the opposite direction here. Again, we'll say if nums.add_i is greater than the max val. We want to say the max I is equal to I, and the max val is equal to nums.add_i. So one thing to note is you could combine these into one for loop, but I did it this way because it's easier to visualize, because you have the min value going from the beginning to the end, and the max value going from the end to the beginning. So the next thing we have to do is we have to calculate how many swaps there are. So what I like to do is I like to first just print out this data. So we'll say min I, %d, min val. So this is just a good debugging technique. Max I is %d, max val %d, and new line to make it pretty, and then min I, min val, max I, max val. So let's make a couple more test cases. So we want, so here's the test case of one element. Here's when it's already sorted. Here's just one flip. We'll do that. Actually, this will be easier to debug. And then we'll just do middle, so that'll give us a couple. So this is one flip. This is when there's, let's put a 0 in front. This is when there's more than one, and this is just another one. So it'll give us, oh gosh, already I have bugs. Nums must consist of values 1 to 10,000 only. Oh, it's because I put the 0 here. Let's make this 4. Oh, and then just very cool. What I need to do. So, or we'll just look at their test cases first. Min I is 5. 0, 1, 2, 3, 4, 5. That looks right. Min value is 1. That looks right. Max I is 3. No, 0, 1, 2, 3. Yeah, that looks right. So you see it did the right one here. So now what we want to compute is R swaps and left swaps. So we'll do left swaps first because it's easier to compute. So if you look at here, this is at 5, and we want to go 1, 2, 3, 4, 5. So it's just the min I value. The right swaps is a little harder. So for example, this is going to go 2 to the right. So it would just be, how do we do this? So really what we need is, we need a right wall is equal to nums.size minus 1. So that's the right wall, because you can't just do nums.size because that would be 6, whereas we want 5. So we want to do the R wall minus the max I. So that's going to be, so the right wall is going to be 5, so it'll be 5 minus 3. And then the last thing we need to check is, really all these can be constants. I don't think it matters that much. I'll just leave them as ints. And the last thing we need to do is check for if the left and the right swapped. So we'll say int correction is equal to, let's do a ternary operator. We'll say if the min I is greater than the max I, it's going to be 1, otherwise it's 0, so that's then what we're going to do is return L swaps plus R swaps plus, actually this should be a negative. You subtract 1. And we'll run this. Cool. So now we'll submit it. And you can see it was accepted. So if we look at some of the better solutions, some of the things you can do is you can, rather than, so we initialized, if you look at ours, we initialized the first elements and then we started looping. Some of the other ways you can do it are they just defined int max and then they put this into 1 for loop. So if you see how that works. So like rather than having to, so this does it initializes the first element and then loops from the second, and this does 1 from the back and then 2 from the back to the first, whereas this, they just defined all them here and then they did the loop. And then, so they, I guess, I think this one might run faster. I guess rather than declaring all the ints, they just crammed it into 1 statement. So if we keep looking, that's one of the common things they do. One of the other things that you can do is, let's see if I can find it. These guys use pairs. So another thing you can do is rather than doing int I, or rather than doing the index, what you can do is you can do this thing. So this min-max element, it returns a tuple of pointers. So then they're calculating on the pointer rather than I. But yeah.